Right, this is the first of three moderated panels that we have this afternoon. And let me just remind you of the topic first of all before we start. This is to discuss whether solid state should be treated as cache or whether it should be treated as a tier of storage in its own right. We'll discuss that in more detail in a moment. But first of all, I'd just like the panel to introduce themselves. You've got about 30 seconds each, so don't overdo it too much. If you'd like to start at your end, Brian, and just tell us your name, which company, what the product is, and 30 seconds worth.
My name is Brian Sorby. I work with EMC. I'm the director of the Western Region VF Cache initiative that will eventually turn into the Thunder initiative. And EMC, as you may or may not know, is an enterprise storage company that sells software and services for the data center.
My name is Keith Brown. I'm a VP of Marketing for the Systems and Software Group of STEC. In terms of what we do, we have STEC is a leading provider of high-performance solid-state storage drives, as you heard from my colleague Scott this morning. But also we sell software packages too, and specifically we have a caching software package that works in the context of solid-state storage. So I'm kind of a neutral guy on this panel today.
Hi, I'm Dan Leary, and I'm responsible for marketing at Nimble Storage. We're a fast-growing vendor that has a hybrid flash and disk storage array, and we're known by our customers for giving them a combination of very strong performance and capacity together, integrated data protection in a solution that's very simple and easy to use.
Hi, I'm Peter Velikin, and I'm with Velobit. Velobit develops high-performance SSD caching software. So our software works with SSDs to create a high-performance application acceleration layer that is able to boost the application performance by 10 times or more, and it installs in 60 seconds transparently to applications without having to change storage or anything else.
Hi, I'm Dave Wright. I'm the founder and CEO of SolidFire. SolidFire is building an all-solid-state scale-out storage system for large cloud computing environments.
I'm Vijay Karamcheti. I'm the Chief Technology Officer for a company called Virident. Virident builds native PCI Express flash SSDs, and which differentiate themselves from the other offerings in the market based on their predictable, sustained application performance.
Okay, thank you very much. So let's just clarify exactly a bit more detail about this topic. So we've seen a lot of presentations this morning from a number of companies, obviously represented on the panel today. And there's probably a split between companies that either have solid state in their arrays, as Dave's just said, an all flash array, and then there are other companies who are selling flash as a cache within devices or within servers. And the question is really, should flash be used as cache, or should it actually be its own tier in its own right? And that's what we're going to discuss. So let's set the scene by being as awkward as possible to, unfortunately, the person who's right at the end there, Brian. And the reason I'm going to go to you first, Brian, is because as a company you sell products that fit all of those niches, and it'd be really interesting to get your opinion as to why you think, what you think, if it's one or the other, or whether you think that's it's a mixture.
I'd like to start off by saying the water's the farthest from me, and I feel that the light is the hottest. Well, I don't believe it's
that was
really
intentional. No.
Actually, EMC doesn't see it as a niche market at all. I mean, it is actually the market that is being created. We're generating or we're generating interest in forums and symposiums like this, to the general population as a whole. But the reality is, this is where the market is going, and those that don't realize that the market is heading in this direction, I refer to them as feeding dinosaurs. So either you get with where the market's heading into the 21st century, or you keep maintaining or building higher and higher walls around the business that you're in. But sooner or later, those walls usually cave in on themselves.
Okay, so let's pick somebody else on the panel. Let's go for Dan. You've got a product that obviously is using hybrid technology. Well, what's your opinion?
Well, I mean, so obviously Nimble, we have a solution that takes advantage of both high capacity disk and flash. And we've taken the approach, as many of you may have heard this morning, of utilizing flash as a cache. And we see a number of key advantages that that approach brings and what our customers have been able to achieve with that. And it starts with, as we mentioned, the fact that we've custom designed our software and our underlying data layout around the fact that we're storing data across both those media. And that knowledge allowed us to do some things in a very different way than other solutions where we saw in many cases tiered solutions that started from assuming that it was just disk and plugging sort of a layer of flash in underneath all of that. And with that, when we looked at this problem early on, we recognized there were some challenges with that. So for example, when you're moving data, there's been a lot of innovation in this area about sort of automating that process of tiering, and that's an improvement. But the challenge we saw is there's a big overhead in moving data from one layer to another. And what we've been able to do by providing, first of all, a cache is be very responsive in the solution. So we've sized our system so that 90+% of the data is served out of that flash layer, and so you can take advantage of that performance that flash brings. But where there's a change in a workload that may mean there's some cold data coming in, we can overwrite or update that cache literally in milliseconds because there's no need to copy data back down. There's another big advantage here, which is because the only copy of data is never stored on flash. In other words, we've always got a copy stored on RAID-protected disk. What we're able to do is get some significant economic savings in the use of the flash. So number one, we don't have to RAID protect the flash, and that can save anywhere from 30 to 50% overhead. Our technology was natively designed to support compression without any of the performance bottlenecks that often come with a compression solution. And we typically see within our customer base about a 50% or 2-to-1 savings as a result of that. And then finally, because of the way we're writing the data in a sequential manner, we're able to get very long lifespans out of even the low-grade commodity MLC flash, and that's a savings of anywhere from 2 to 4x or even more depending on what you're looking at. And all of those capabilities sort of combine together that give you about a 10-to-1 or better advantage in sort of cost. So we look at it as a way to build a system that can support a wide variety of workloads. Lots of data that's not frequently accessed doesn't need to be on flash, and we want to store that in the most effective, lowest cost manner on very high capacity disk. And as a simple example, snapshots are a great example of that. We've talked a lot about sort of primary data in this discussion earlier today, but integral to all of this is how are you really protecting that data? And we found a way to do that very efficiently, eliminating the way to move that data, and having a system that has both flash and disk with the ability to move and utilize the data as we have, we think gives some key advantages out there.
So just to interrupt you there then, what about if you've got a high I/O workload that is across the board? So, something that needs that I/O. Dave, I mean, obviously you've got an array that's doing exactly that across the board. I'm guessing you're not in the cache camp on this panel.
Well, so first of all, I think it's important when we look at the terminology to really think about what we're talking about with caching or tiering. For example, a lot of people when they talk about tiering, they talk about technologies like automated tiering or sub-LUN tiering, or the ability for the storage array to move data automatically up and down between the tiers. And in reality, I think while there may be some technology differences between that and what you would typically think of as caching, that is essentially a caching technology. That is a technology where we're making automated decisions to have certain data serve faster than the other based on how hot it is or is not. And really, it's just a type of caching. Okay, there's some technical implementations and the differences, but I would argue that automated tiering, as it's implemented by most storage arrays today, is really just a form of caching. So the question isn't necessarily caching versus automated tiering, because I think you get similar benefits from either of those technologies. The question is really a caching technology versus a pure tier of storage, a layer of storage where either an administrator or an application needs to decide to specifically place data in that tier. So are we going to let the storage array decide what data is hot and goes in flash, or are we going to leave that decision up to the administrator or up to the application to decide where the data is placed versus in a disk tier versus a flash tier? And I ultimately think the world is moving to a place where it will be typically the application that decides which data needs to be optimized for performance and is put on flash, and which data needs to be optimized for capacity and put on disk. And the technologies, the caching technologies that we see today are really just a legacy of the fact that previously, there only ever was one type of storage, which was disk. And all the applications and all the operational things today are really around, you put it all on disk, and that's, it's all the same. And they're taking advantage of the fact that applications actually do have different access patterns, and they can optimize around that. But as time moves forward, I think we are going to move into a world where applications will decide which data needs to be hot and needs to go in flash, and which data needs to be on disk. And the reason is that at the end of the day, that application has far better understanding of its data and its data access patterns than any storage array ever will, because it has really no deep understanding of that data. All it can look at is historical information and make guesses about where that data can go. And that leads to a lot of issues with unpredictable performance, a lot of issues with different workloads getting different benefits from the cache. And in multi-tenant cloud scenarios like where we focus, it really leads to an environment that is just very difficult to manage and very difficult to control from a performance perspective. So that's why over time we think flash is part of this tier that we call performance optimized storage, and disk is primarily this capacity optimized storage tier.
Okay, so does that play into the hands of the people who would develop software that would allow you to cache at the application layer? Anybody like to comment on that?
I'd like to comment first on the concept of tiering versus caching. I actually don't think...
You might have to talk up so they can hear you, or I can hear you quite well.
Okay, so I wanted to comment on tiering versus caching and whether they're the same or not. I don't think they're the same. I think that tiering actually is not a very good idea. I think it's a dream to think that application or a software can decide in an efficient way where to place data. I mean, 10 years ago I was at EMC and HSM was the big thing, never worked. I don't think tiering would work again. It will be quite a while to do it. So in my opinion, we need to keep things simple. So I think there are legitimate reasons to place data on SSD as your target. And
can we go back to the tiering?
Yeah.
We've been selling tiering for a couple of years now, so to say that it doesn't work, that would be factually.
Okay, let me put it another way.
Also to address the caching in the software,
yeah.
Leaving it up to the software vendor or the software application designer to make it smarter to work onto a storage platform seems to be asking a lot as well.
I agree about not leaving it to someone to decide. What I'm also saying is that practically to have a system that decides for you in an efficient way when and how to move data is expensive, and the amount of software that customers pay to get this system sometimes defeats the benefits. And also, it's extremely scary from an IT manager point of view. I mean, I've yet to meet an IT manager, maybe you guys know, that is looking forward to get this complex system that will make things decide when to move, when they can keep things simple.
But if tiering's working correctly, he doesn't have to think about that. The system does that for itself.
Sure, and then he deploys another application or changes the workload, and he needs to change it.
And again, the system's smart enough to address that. See, that's going, fast forward 10 years. I don't mean to be picking on anybody, but it's like that's what systems are delivering today. I mean, Nimble, right? I mean, that's your mantra, and the same from an EMC perspective. What I really see is the software that enables that coming outside of the platform, right? Instead of having to buy another box, right, and put it into your environment, the future is buying the right software to allow this data to tier across the many platforms that you have in your environment. So I mean, like it's pulling it out of looking myopically at just one box, one platform.
Isn't that what his company does though? Is sells software that allows you to automatically, again, where you call it tiering or caching, you're basically moving hotter data into a faster medium.
It's both, though, if you do it right.
My opinion is, back to the company, what makes sense if you really want performance, deploy it as a cache, because you don't have to disrupt your existing storage and infrastructure, you don't have to touch anything. Disk is so much cheaper, or any whatever tier you have, that it doesn't cost you that much to keep the things the same. It's actually cost you more to rip it out and do something else from an operational point of view. Deploy SSD as a cache, get your performance. There are many legitimate reasons, and you should think about deploying SSD as your primary tier. I mean, there's the operational cost, there is the power, there's the form factor, many good reasons why it would be. But if you're really looking for a performance boost, tiering is complex, guys. companies. I mean, I think we should think about what's simple. Put something in, get it to work, go home and don't worry about it.
It depends on if you're solving.
Sorry.
I'm sorry. No, I was going to say.
Coming next, Keith.
Yeah, sure.
Okay. Yeah, so I was going to say it depends on whether you're solving today's problem or where you see the trajectory going, right? Which is, and so therefore when you say is it cache or is it a real storage tier, I think the answer that comes to mind is it's a cache today, but it is definitely going to be a real storage tier in the near future. And the way, and I kind of, Dave I think did an excellent job in kind of trying to say that we should really get our terminology straight and what we are talking about, right? And to your point, even when you're talking of caching software or is application managing the movement, it is ultimately about where the decision-making logic for what resides on these different forms of storage lies. But as long as you accept that there are different forms of storage, that you want to make decisions about which data, which access patterns are better supported in one tier versus the other, or one layer of storage versus the other, it is tiering, right? Caching is a short-term fix just because you feel this technology is risky, because you feel this is more expensive, and because applications are slow to change, to adopt to different ways of interfacing with it. But it is a given that applications do need to interface with it differently. So it is ultimately going to be a tier.
So one of the things I thought I heard there that I do disagree with is that applications are not the place to be doing this tiering or deciding what needs to be cached. And I would say that it's quite the opposite. Like, what is the entity that knows the most about the data that it's using? And whether it needs to be cached or it's going to be needed again, or whether it's more transitory, it's the application. And of course, not all applications are aware of things like flash resources that are off to the side and can shuttle things off to the side and so forth. But there are ones that are, and so applications that that are written around doing aggressive caches internally, I think that's the most intelligent place to do it. And one example I would throw out of that is Oracle. Oracle have the Oracle database itself obviously has a big use for internal caching. It has a giant internal cache called the System Global Area, and on Oracle have actually extended that with some software out onto Flash. They call it their Smart Flash Cache software, and who knows the most about what should be cached in the context of the Oracle application? Is it Oracle, or is it some weird thing in the I/O stack trying to do guessing games, or is it the storage system? It's Oracle. Oracle knows the most about it.
Can I just? I'll come back to you in a second, Dan. Can I just question that for a second, though? Do you not think applications are like users? Whatever you give them, they'll take everything that they can get, and they'll always say that their stuff is the best and
possibly
the fastest and
possibly.
The rest of it. And if you're giving the application the opportunity to make the decision, that might be counteractive to a mixed workload or other things like that.
Yeah, no, obviously that's where I think there's a place for some intelligence, maybe even some human intervention, where you've got to kind of keep things corralled and segmented.
Or as vendors, it's our responsibility to offer things that are isolatable or partitionable.
Yeah, and I think it's important to note that caching really does optimize from the storage array's perspective how that I/O works. So if you're saying, I want the most optimal thing from the storage array's perspective, it may do a pretty good job of that. But from an application's perspective, from the perspective of an individual application, you lose predictability in your performance. So in some cases, in fact, really in almost every case, it actually makes sense to trade some optimal performance from a storage array's perspective to have an application that can consistently, predictably get optimal performance. And if you say, I'm going to allocate this much flash to this application, this much flash to this application, and then let that application manage that flash how it sees fits. The important thing there is that it's going to get the same amount of flash and consistent performance day in and day out, and it's not going to be contending with other applications and other resources to get that level of performance. And that's one of the big issues with the caching or automated tiering technologies as it exists today, is contention that is hidden from the application layers and that it really has no visibility or control over. And so that's why I think moving into the application, even if you trade some kind of idealized optimalness in terms of how you're allocating your IOs, ultimately it leads to a better environment and more consistent, predictable performance for your applications.
No debate there, but there is a good argument to not carve out pieces and hand them off to applications. and efficiency seems to be the primary reason why people don't want to do that, right? And so that's so you have to manage that.
Applications that are smart enough to take advantage of that. Right. Most of us in the corporate world run the applications in the data center the business guys picked, and if they don't have that functionality, then the question is, how do we deal with that?
And the point is that I believe it'll be years before they have the functionality. So I agree that in the far future, that's a great thing and it will happen. But it takes time to build a real world application to do that.
But here's the way you deal with that. Okay, you may carve up what looks like static allocation, but then you use virtualization technology, okay, at the storage level, to share a larger pool with those applications. And that's essentially what we've done, is allow you to carve up that performance level, but you can essentially over-provision, right? You know not everything is going to use all that performance at the same time, just like you over-provision capacity within provisioning today. You can do the same thing with performance, where you can allocate performance to individual applications, give them the performance they need, but then globally looking at the overall performance needs, size the storage system accordingly to be able to deliver that.
But that's exactly what a good caching system does effectively, right? Because the reality is, if we look at across, say, a SQL Server, typical SQL Server database, the working set, what's active at any given time is a small subset of the overall data. So, well, in some far distant world, there may be applications that are intelligent enough to be able to predict better than the storage what will be hot and when and move it around. The reality is they weren't designed that way. And by having a system that can be very responsive and recognize when something's changing and moving in, I think this is part of the challenge with typical Flash is, because we're looking at systems that have historically been able to move data on the order of an hours or a day, I think a lot of the arguments that I'm hearing down here, they make a lot of sense. If you have to wait 6 hours to get data in Flash, that's not going to be acceptable for most applications.
So the counter to the point you just made is, why don't people always rely on virtual memory? Why do they manage DRAM on their own using data structures that they explicitly put in DRAM?
We can get orders of magnitude larger.
Sometimes they do, but
orders of magnitude larger. This is a whole different world.
And trust us that this is going to be that order of magnitude larger too. And I think you bring up a.
Let's get back to the let's get back to the corporate enterprise user.
No, I had a comment to his question.
Okay, but I think it wasn't Howard that had a question. I think there was a gentleman sitting behind him that had a question.
The question is, again, we all talk about the end user at the end of the day, right? So, and I don't know if the end user really cares about if we call it tiering or caching, right? But they do care about predictable performance metrics and quality of service. So as long as all of you gentlemen and your teams can provide a way for them to actually manage their expected outcome, everybody will be happy. I mean, is that a fair statement? Would you say that that's what we're talking about, quality of service and predictability?
So that, I guess, just summarizing that as a question, I think what you're saying is the users don't need to necessarily want to care. All they want is the performance that they expect is guaranteed.
Yeah, so the way I'm hearing that question is, what is the best way for an end user who's paying for this stuff to get a return on their investment? Is it to use this piece of hardware as a cache, or is it to explicitly have the application manage it, right? And so to a comment that somebody else on the panel made, there are definitely applications that are becoming Flash aware. Oracle is an example, and there are others as well. And they are not really they're treating it as a cache in some global sense, but it's application managed. It is making explicit decisions based on information that the application has. I think the position that...
Sorry.
Go ahead, Keith. Go on.
I was going to say, I just wanted to share, what I've heard from, I mean, here are a lot of opinions and theorizing here, but, what I think really counts is, what customers are finding compelling, or what I'm, hearing from people who are deploying this stuff in the market. And, to come down on the side of caching here, I think the most compelling case, or the reason so many people are looking at the caching approaches is, yeah, it's nice to get the application speeds up that come from it and so forth, but it's really actually the offloading of the, I don't want to say legacy array, or the traditional array architecture on the back end that's really lighting up people's eyes in terms of the savings of dollars. Because if you've got a relatively expensive back-end primary storage system which is starting to creak because of all the load you've put on it and the I/O blender of virtualization and all these sorts of things, and you're looking at a really expensive upgrade you'd have to do back there to keep it going, instead of that, you can just deploy a little bit of you know, high-performance flash storage on the client, some caching software that'll offload massive, potentially massive amounts of IOPS from the back-end array. And there are, you know, some real huge savings to be had there. Yes, it's, you know, the caching software and the client-side flash is doing good stuff for the local applications there, but it's that offloading of the array, avoiding an upgrade, making it faster for the guys who aren't cached, because you've offloaded all the cached guys from that array. You know, that's the real economic benefit.
But aren't you by definition then saying that it's a stopgap technology? I'm going to save one generation of upgrades on my array because the array technology isn't good enough to do it without this
That's
Band-Aid.
not what it's doing at all.
Yeah, that's not necessarily a bad thing.
If you're looking at a 36-month refresh cycle and you find out at 10 months that you undersized an array, as an example, or more applications came onto your environment, by taking a cache approach from a server-centric perspective and alleviating that for a lot less money than having to go back.
I'm not saying it's a bad Band-Aid, but it's basically a Band-Aid to keep me from upgrading.
It's not about being a Band-Aid, it's a solution.
It's a solution.
Band-Aid is a solution to bleeding.
So is stitching.
Brian, can I just ask you a question? How often does EMC undersize an array when they sell one?
Every time.
Actually, what we're finding with the VF Cache approach is customers are coming to us, and when we're deploying this technology, their arrays are performing better. Because 50% or more of the activity happening on the array is on a read. And what happens is writes start to go through the roof, because it no longer has to worry about going out and reading and caching data that may sit up in the server as a more efficient means.
So I know, Brian, that you're on a timeline that might be a bit short. So I'd just like to ask you another question, because we went down a little avenue there that I think is worth discussing. And that's how the customer makes a decision about what's the right technology and how they should approach it, if it's all about just getting, you know, cost saving and benefit. There's technology that sits at the server level, and obviously EMC sells all of this, which is why I'm asking you the question as well. There's stuff that can sit in the array, and then there can be arrays that have got cache in there flash in there as a cache tier. How does the customer make the decision about what's best for them? How do they work out the cost and the ROI on that?
Well, it really comes down to where the customer is in their deployment cycle. You know, when you look at it from a startup point of view.
That sounds, sorry to interrupt, that sounds slightly like a corporate response to say.
No, I don't want to go down there. I'm just saying that from a new deployment point of view. How's that?
Okay.
It's something new, and you learn from that.
Yeah.
And, you know, from a server vendor or a stack vendor point of view, right? It may be adding value to a situation that you knew was bad going in. I'm trying to be as clean about this as I can. But the fact of the matter is customers size their environments. They may be correct or they may be incorrect. It's up to the vendors that they work with to provide solutions to help them through that process of sizing correctly. I don't think that there's a one type of either caching or tiering approach out there. I think it's everything. And, you know, to get to your point, it's EMC currently is providing that all the way to the backup and the archive. So, you know, it's kind of an unfair question for me.
Dave, I think you've got sorry, go on, Peter, go ahead.
Yeah, so I think we're onto something very good, and I agree with the trajectory. So how the customer makes a decision. So I think one of the biggest problems that people face, and these are people that are making the decision in the IT department, is that thinking of a new SSD solution, it's a big deal. I mean, there's so many ways to deploy it, so many ways it can go wrong. There's so many things you need to fix. We're talking about applications, the array, other things. You don't really know. You may solve this bottleneck, but maybe you will run into another bottleneck. So it's a very risky thing to go. And caching allows you a way to go and try it out in an easier way that's much more cost effective to scale. So I think it's actually helping adoption of SSD storage, because it gives you this lower cost way where you don't have to bet your career in your company's future or IT future on something that may pan out or not. So I think it's here to stay, and until we have all those different things and places to go wrong, that'll be a very, very compelling technology, and you can do more and more to it to help manage all these intricacies of different places that you need to fix.
Yeah, I mean, just to make a quick point, I mean, at a high level, I agree, right? I mean, ultimately, what the customer wants is they need something that's simple, and at the end of the day, it really comes down to efficiency, right? How am I going to get the performance I need, the capacity that I need? And historically, the trade-off has been, you know, disk, particularly high capacity, low RPM disk, you know, gives you great terms of capacity. Flash is going to give more than enough performance, but even when we do dedupe and compression and others, the costs become a challenge. It's how do I find an efficient solution, and it's something that I can kind of set and forget. I mean, that's what we hear all the time. And how do I build in enough application intelligence so that the system can do the right thing behind the scenes? And what we found with the Nimble customer base is they're getting often 5-10 times the performance that they had before. So this concern about, am I right at the edge, or have I got a system now that can't quite get me there, goes away, but they've been able to do it at a price and a level of simplicity that was less than they would get anywhere else. And so if you can eliminate that trade-off, we found that that's a really nice way to handle it.
So it seems to me, you know, this decision is so dependent upon the customer context. You know, I just shared the compelling economics of caching, given a customer base that's got traditional back-end storage that's struggling and might need to be upgraded. You know, caching really works well there. Share with you another place where I found very little interest in caching. And a few weeks ago, we attended a MySQL conference here in San Jose. It was the Pecona Live MySQL conference. Lots of MySQL DBAs all in one place. And we were asking them, you know, we sell a caching software packages, about the interest level in caching, and there was very little there. So as to probing as to why, you know, MySQL, it's kind of arguably the smaller end of the database market. We're talking about the sub-terabyte databases here. I never thought I'd think of a terabyte database as small. I'm kind of old, but apparently that is the case now. And you know, one of the compelling economics of Flash applied to that market. You've got a MySQL database, you want to get more performance out of it. You know, the two ways choices you have of doing that are with traditional storage, you employ a really expensive DBA who maps the database out to all the different spindles with precision and charges you a huge hourly rate and so forth to try and crank the performance maybe 1.52 times. Or you can just dump the traditional hard disks and jam a big lump of Flash underneath those databases, and you get like the feedback we were getting is 5, 6, 7x performance increase almost for nothing, you know, without any huge planning or without, you know, having to pay lots of money for database experts and so forth. You know, you just put the whole thing on Flash and you're done. You can walk away from it. So that was an example where I didn't see a lot of need for the caching approach. It was,
and I think that's
a
very telling example, and it's consistent with the trends we are picking up too. So, you know, how do customers make decisions? So there are two dimensions that we see. Is it legacy applications or is it a new application? Is it a mix kind of an environment where you feel that, you know, you don't really have control over the applications and their mixes? Or is it a narrower set of applications where you have control? So typically new deployments, application deployment settings where you have a fair bit of control, people tend to have gone with the tiering approach. Legacy applications where I'm running into the limits of my existing deployment, I want the next level of, you know, performance from it, let's kind of throw in a Flash-based cache. Or it's an environment where there's a mix from lots of workloads, I don't really know who's going to benefit what they're doing, I need some source of intelligence that's closer to the storage, use it as a cache. So that tends to be the way it breaks out for us.
I think we've got another question from the floor.
This conversation has been largely focused around Flash devices and mechanical disk as it exists today. 3 years from now, a Flash bit will cost a fraction of what it does today. How will that affect your attitudes and your architectures around caching and tiering?
So I actually think that's a really good point, because a lot of this discussion around caching is predicated on the fact that Flash costs significantly more than disk, and therefore it should be a relatively smaller portion of your capacity. And the reality is, while there is a delta between Flash and disk today, number one, the data reduction technologies that several people up here have talked about can reduce that delta significantly. So rather than a 10x difference, you might be dealing with maybe a 2x difference in dollar per gigabyte, if even that. And as time goes on, yes, disk is going to get larger, but flash is going to continue to get cheaper as well. Disk is not going to get any faster. So when you look at IOPS per gigabyte and some of those other metrics I talked about, it's not going to get any better. So flash is going to get further and further, and eventually you're going to get to the point where you say, does it, maybe flash as a cache makes sense if I can only afford 10% of my capacity in flash. But once flash gets to the point where, you know what, it's 50, 60, 70% of the capacity, at that point, it doesn't make sense to have it as a cache at that point anyway. That just almost doesn't make sense at all. And so we really think that that if you focus on the fact that flash is more expensive, what you're really trying to say is, well, I have some applications or some data that doesn't need that performance, so therefore it's wasted if I put it on flash. We think a better approach is to look at a collection of data, a collection of applications, and the overall capacity and performance requirements of those set of applications, ignoring what any individual application or piece of data needs. Look at it in aggregate, and then virtualize the performance of a set of flash across the entire system, so that you're not wasting performance just because a bit of data isn't actually getting accessed that much, because the flash device that it's on is also serving I/O for many, many other volumes that have much higher levels of performance requirement. If you can virtualize and share that performance across a wide range of data, across a wide range of performance needs, and then essentially use performance virtualization to steer that I/O and guarantee that I/O to the applications that need it. And the applications that don't, yes, they're taking up space on the flash, but they're not wasting any performance. The performance is going in other applications.
Right, so
that's a better way to deal with it.
In that view, you're sharing the cost that you pay up to get the performance, but not necessarily the cost you pay up to get the capacity.
Exactly. And as flash gets cheaper, that becomes much
more that's true, but to generalize that question a little bit, if you look at the reasons for caching, cost is definitely one of the compelling reasons today. Nobody wants to kind of pay up. I think there is a sense that the technology isn't mature enough for widespread deployment. That's another reason. Caching appears to be a safer option. Right? There's a third value which I think will persist longer term, which is that caching makes choices about what data resides in which tier, and one could argue that somebody who is thinking about this upfront at the storage level is probably better equipped to make those decisions than every application that's out there. I think that reason will stay, correct? But that said, I think another dimension that hasn't come up in this discussion and hasn't in the questions yet is that there seems to be this core assumption that we'll interface with our flash-based storage the same way that we interface with standard disks, etc. So we'll still be doing block-based access or file-based access. And those of you who heard my talk in the morning would kind of resonate to the following, that we believe these things offer fundamentally different characteristics, that there will be new APIs that will get introduced. And when those new APIs get introduced, it's not quite clear that transparent caching quite has the same role to play as it does today. You want to know that you're interfacing with this layer. It offers you certain reliability properties. It offers you certain access properties.
So based on that answer, I was going to come to you, Keith. You probably have a smile on your face because we're saying that
he always smiles.
It's going to be across the board. So, what's your opinion?
Yeah. So the comment about flash getting cheaper, I think, it's absolutely true over time, and obviously more is going to move to it as it becomes more affordable and people can move more of their data to it. However, you've also got this other metric of data growth as well. So yes, flash is going to get cheaper, it's going to get more popular, more stuff is going to be stored on it. That arguably negates the caching argument a little bit. But you've also got massive data growth going on in the market. I have Facebook friends who post pictures of their lunch, for crying out loud. I was thinking 20 years' time there's going to be this picture of a long-forgotten lunch sitting there on a Facebook server somewhere that no one cares about. Are we keeping too much stuff?
I've seen quite a few pictures of lunch already from what we've had.
Yeah, I don't know if anyone did that from me. It didn't look very picturable. But anyway, so there's this phenomenon of data growth, and to say that the capacity optimized part of the storage market is just going to just go away is I think is wrong, and there is going to be the place for the high capacity disks. It's just that the trending there is going to be higher capacity but slower. On that side, the performance top tier obviously goes to flash. And then the disk arrays become like the tape libraries are today.
And the other thing, I just bring Peter in a second, because I just want to, because I'll forget the point.
Yeah. So
I don't make it. Just let me. If I had to explain what I mean, and then obviously you can answer as you feel. But obviously you've got a product that is accelerating stuff within the server potentially, as are various other products. So just because Flash has got cheaper doesn't mean you don't want to reduce latency within the server. So that surely means that there'll still be a differentiation.
That's the point I was going to make. So
Excellent.
first of all, Velobit, thank you for the setup.
Yeah, no
So Velobit, you could actually deploy, you can accelerate cache that doesn't have to, Flash doesn't have to be just in the server, it could be in the array, but most of our customers choose to deploy it in the array for latency reasons. And I think my answer to this question is, I think we need to separate when it's in the array. Clearly as Flash gets cheaper, and there's many compelling reasons why more and more Flash will be deployed. But there's the performance argument, which argues for deploying SSD in the server, and I think caching plays a very important role there, because what it gives you the ability is, yes, you will boost your infrastructure, but by having SSD caching in the server, gives you a very nimble approach to boost performance and scale it on a per server level. So I see that, yeah, you will have this Flash array and you'll have primary storage as Flash, but you also will have another type of SSD cache that will be deployed in the server, which will help you scale performance, and it will give you this nimble way to grow your architecture so you don't have to over-invest for things that you don't need. The right way until you need to bring up everything.
So you just mentioned Nimble a couple of times there, and there's a person from Nimble sitting next to you.
Yeah,
He has an opinion as well.
and no, I think there's some good points raised here. You know, Flash is going to get cheaper, but let's not forget, you know, disk is on that same path. We've had a temporary hiccup with some of the supply disruptions, but let's remember we're at least a factor of 10 and often a factor of 20 or more difference in cost that's here today. Even if that narrows a bit, and there's I think varying opinions on that, there's also varying questions on how Flash is going to get through the next couple of generations as the lithography gets smaller. You know, there's some issues that may start to slow some of that gap that's closed a bit. At the end of the day, it still comes down to what you want is a solution that can take advantage of where capacity disk is best and where Flash is best and has the responsiveness and efficiency to do both. So I think what you hear sometimes is where there's a hammer and all we've got is Flash, we're going to talk about how Flash solves all problems, but it's clear there's some opportunities for both, and the question is what's the right way with intelligent software to leverage both? I think that's not going to change in the next 2 or 3 years.
I don't think anybody's saying that disk is going away. I mean, I said in my presentation, I'm absolutely convinced there's going to be a capacity optimized tier of storage on disk. I think the question is, is that truly a separate tier, or is it all part of one storage system with storage software making the decision of what goes which? And I honestly think the answer is an answer of scale, right? If you have one storage system and you get to buy one storage system, and that is your entire storage system, yeah, that better have disk and Flash in it so you can get the best of both of those worlds in it. However, when you get to large scale and you have lots of applications and you have lots of data and you are operating at data center or cloud scales, it doesn't make sense to have one storage system that tries to do everything, because it's going to be the best at nothing. You want a capacity optimized storage layer and you want a performance optimized storage layer, and you want to be able to provision across those, across your entire data center and across your entire range of applications, and deliver to that application the performance, reliability, and capacity requirements that it has. And you're going to have a very hard time doing that with a single fixed platform that's making those decisions on its own.
Okay, we're coming towards the end of our time. So we've had a couple of questions from the audience. I just want to see if anybody else has any questions they'd like to ask the panel in the next few minutes. And we have another one at the front. Go ahead.
Yes, it's a really interesting point which we made there, and absolutely I think a lot of us agree. What about this whole notion of grid storage together with the computing piece, right? I mean, Google is not completely just out there in the left field with the Google file system like and scalable data centers, right? I mean, we're seeing other folks in the industry doing that. I mean, what do you guys care to comment on how that may look like? Because a lot of folks may argue that we may go completely in a different direction.
No, so I wanted to make the point when Peter was talking, or made his comment about the scaling advantages of a per server cache versus that of an array. In some sense, to me, that looks like an artificial distinction. You can build a scalable tier either by ganging multiple arrays together or by layering software using a Google-like storage approach across multiple servers using Flash as well as you can over disk. So will it take you into a completely different direction? I don't know. I think fundamentally the question that this panel is about, or at least the way I understand it, is, are you going to be making different decisions about the data that goes into a largely flash-based storage subsystem versus a largely disk-based storage subsystem? I don't think anybody appears to be taking the position that disks are done. All we are taking the position is they are not in the data center anymore; they are only in the cloud. Right? That's the only position we are taking.
Yeah,
But,
that architectural question is a good one, though, because when I look at the clouds that are really scaled out, so the Googles and the Facebooks and the Amazons and those guys, I don't see a lot of good news there for storage system vendors in general, because I don't see storage systems, like I don't see any Symmetrixes in the heart of those things, or I don't see any Hitachi arrays or whatever. They are using a shared nothing, basically a shared nothing DAS architecture across the nodes, and very clever software that kind of like distributes the data out and can make that work for the application context that they have. So I think that's an area where clearly we're back to the DAS model and making the DAS model work, and that DAS model is in many cases it's traditional fat SATA, it's capacity optimized spinning disks, but also for the performance tiers you're looking at direct attached flash, so it's direct attached flash.
So if only had some
closer.
Yeah,
but there is kind of clustering in those architectures, but yeah, I don't see storage system vendors in the really big ones. I just don't.
Dave? Yeah, go ahead.
so if only someone had a scale-out storage system that used commodity hardware and internal flash clustered together with smart software.
You think you can get in there? You've cracked it. All right.
But I think the point is right, that at large scale, scale-out grid architectures are the way to go. Google File System is a great example of a capacity-oriented architecture to do that. And the question is, what are performance oriented storage systems in that type of environment going to look like? How are they going to scale? How are they going to be managed?
And what do I do until SAP runs on that architecture?
Well, again, or can you make that architecture look like a traditional block-based storage system? In which case, it's not an issue. But I think that is where things are going, and that's why you don't see these legacy storage architectures in those environments, is because they're not scale out, they're not shared nothing, they're not. They're monolithic systems that don't really.
It's not fair to say that so-called legacy storage architectures are like none of them are scale out, because there are examples where they clearly are. There's examples in NetApp with the scale out architecture they have in
16
ONTAP.
nodes is
There's
not
examples in Isilon. There's there are scale out architectures in that
There's
space,
a small number.
And those systems are not being used in that. So I don't know that your argument holds that so there's a magic thing that you've cracked and that you'll get in there and Facebook will be you know what I mean. I can see the.
I think the SAP comment was was very relevant, because I think the question that we have to get comfortable with is the types of grid-based storage architectures that the Googles, Amazons, Facebooks of the world are working. Do they work because it's a relatively narrow set of applications that are using it? That solution is able to deliver both the capacity and the performance needs for that class of applications. If you had a more mixed set of applications, which you can't talk to every developer and they're not legislated to use that architecture, would the answers be different? And I think there is a role for alternate storage solutions.
Data protection is the other, right? You have to build all that in, and so if you're in a position where you can custom build all of that for a large scale application, it's practical. The thing is, when you're in a typical environment that's dealing with dozens of applications, that's a very challenging problem. So.
Okay, go on.
I think there's also one interesting point to make about these distributed architectures. So I think long term, I agree. There is going to be a shift and a change with the SSD storage, but we need to think practically what it takes to upgrade. And I'll take an example. Zoom in for one of our customers or others that we've talked. So whether they deploy a Solar or a Hadoop, a self-healing architecture, and they want to upgrade, the upgrade still means something to the IT guys. So for example, ripping out and replacing the servers or adding more, you can't take all of them at once. You can take only a few at a time. So one of our customers was looking at 3 to 4 months migration so they can take several servers at a time and wait for them to self-heal and go forward. So I think there's still room for caching to help you manage those transitions. I think we need to keep thinking, what does it mean in the real world and the complexity of doing this thing? The end result is great, but how do we manage?
Okay, so any more questions on the floor before we just summarize? And get everybody to do one last summary. No. Okay. So why don't we just summarize what we've discussed very briefly, 30 seconds a minute, starting at your end, Keith, if you like.
Yeah, okay, well, I'll
up.
just quickly say, that this, again, I think it's been said before, this isn't sort of like an either-or question. I think there's clearly customer context for both use cases of Flash, both the caching use case and also the place all of your primary data on there. Depends on the size of the data in play, depends on the type of the existing legacy architecture, which one customers might choose, and what really drives it at the end of the day is the dollars. Which one really saves customers money, and that depends on their context.
Thank you.
Yeah, no, and I agree. And I think to follow along with that, it really comes down from the customer standpoint of what's simple, what's something that I can implement given the limitations they typically have within their IT organizations, and what gives me the most efficient way to meet the performance and the capacity needs, the data protection needs, and to do it at a budget I can afford. I think that's ultimately what it comes down to and what's going to drive these decisions.
So I agree also that there'll be two cases. There'll be the primary storage being on Flash, and there'll be the caching. I think what really will drive and continue to drive is the complexity of the implementation. The end result in dollar and cents may make sense, but what it takes to the people that need to make their decision and risk their career will make important. It will be an important driver for the decision. So simplicity, in my opinion, will rule the day at the end.
So I think it's very clear that at a small scale, caching makes a lot of sense. If you have a single storage array and that has to be everything, it makes a lot of sense. But I think if you look at the larger trends and the larger scale things that are happening in computing, it's really about the move to computing as a utility. The ability to provision and dial in the storage, the networking, the computing that you need at any point in time. And if you want to be able to do that, you need to be able to dial in a predictable, consistent level of performance. You need to be able to say, this application needs 4 cores of CPU, 16 gigabytes of memory, 120 terabytes of disk space, and 10,000 IOPS. And that's that application that I just provisioned. And that type of architecture is extremely difficult to get to with a cache-based architecture. You need a storage architecture under the covers that can virtualize performance, guarantee that performance, and deliver it to many applications at the same time. And that ultimately is where I think this is going.
So we've been a relatively non-controversial panel. We seem to be in agreement with each other. So just to inject some controversy into the process.
Right at the end, yeah.
Right.
Okay.
So I guess I'd summarize it this way. I think it's caching and tiering today, and largely tiering tomorrow.
Okay. I hope you found that discussion useful. I think just like to take an opportunity to thank the panel, and thank you very much.